Hello everyone, welcome back to Advent Code 2024. I'm going to start on day 6 in a few minutes here, but this is the first day I actually had something to do in between recording sessions, so I wanted to show this. So I talked before implementing yesterday's problem, and then also after implementing it, about how isn't this kind of a topological sort? But I didn't actually implement it that way. And I was hoogling around, I guess, for topological sorts, and there is one in DataGraph. Which, the problem I had with that, I didn't try to do it until I was done with day 5 already, but then I was like, I'll do it overnight. The problem with it is that, DataGraph, its graph structure is somewhat not opaque. It's obscure in a way. It's not convenient to work with. It doesn't accept here's a list of edges and nodes and so on. It just everything here. Actually I can show you, right? Data graph. So where we left off last, I guess I'm publishing these in the morning, so it would be yesterday morning, but I'm doing them at night. Well, they said, a graph is an array from vertex to vertex, list of vertex. It's like an adjacency list, and a vertex is an int. And so, I was like, isn't this all rather primitive obsessed? Why does it work this way? Why doesn't it have some higher level model of a graph than an array of ints to list of ints, or an array of lists of ints indexed by ints? And that was about where we left off. And then I scrolled a little bit further down, and I saw that it has this graph from edges function, which builds you this ridiculously primitive structure out of a reasonably meaningful data type. And even the thing is, even if all it gave you back was a graph, like a list from vertex to an array of lists of vertices, that's very unpleasant to get anything out of. So it doesn't just give you a graph. You give it a list of edges where the items are a key, which is what you were going to use, some unique indicator you're going to use to identify a node, and some label for the node, which might not be unique or might not be sortable or whatever, and then a list of all the other edges that this node has an edge to. So you give it a list of these specifications for nodes, and it gives you back a graph, so that obtuse structure up here. But it also gives you back a function from vertex, so one of the nodes in this very obtuse structure, a function from vertex to the original data you used to describe the node. And then also this function that takes a key and tells you, hey, is there a vertex here? So you have to kind of translate your problem into DataGraph's data structure by calling this function, and then do your operations using the functions in DataGraph, like topsort. Where is it? Topsort. So you give it a graph, and it gives you back a list of vertices. But vertices are just ints, so you have to consult the function from vertex to node that was given to you when you built the graph to see what nodes it's talking about when it gives you back some vertices from topsort. But that's I guess, generally speaking, how you're supposed to use DataGraph. So I did that. And it comes out a lot shorter because I'm not doing any real algorithmic work here anymore. I'm just leaning on topsort. What I have is a reverse topsort because I have the edges going the wrong way for a regular topsort, but DataGraph has both, so that's fine. So all we really do is we say reverse sort the graph, and the graph is, we construct it by calling graph from edges, passing it the list of pages we want to work on. And, to figure out what edges should actually be in the graph for a page, we have to call. I designed this depth function which takes all the things it depends on and intersects those with the ones we're actually trying to print, i.e. the Q. So we do that, and then we have to convert each vertex that top sort gives us back into a page using page from vertex, which just calls getNode and throws away everything but the page number. So this would have been, I mean, I want to say less error prone, but I don't think we actually had any errors in this implementation. I just it took me a while to get something to type checked. Okay, so anyway, that was what I did between yesterday and today. So what's new today? Part 6, day 6. Guard Gallivant. The historians used their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely? You start by making a map, your puzzle input, of the situation. For example, so hashes are walls and dots are... I assume the guard goes forward till he hits a wall and turns right. You can see my cursor, right? Yeah, so he goes and then he leaves. So we're going to, for part 1, I assume, we're going to mark all the squares he visits or count them. Or count how many times he visits them or something. Lab guards. Follow patrol protocol. If there's anything in front of you, turn right. Yep, otherwise go forward, of course. That's what this map... This map would not be interesting unless that were how guards behaved, basically. So that was how I was able to guess ahead of time how they would say a guard behaves. Why are you telling me what the obstacle is? I guess it doesn't matter. Universal solvent, very funny. I remember reading this in I don't know, when I was a kid, somewhere in between 10 to 15, I would guess. There was a book of riddles or something that I read at least some of, and I still remember one of the riddles. I don't know why this one stuck with me, but there's this, in ancient times there's this king, and he has an alchemist, and the alchemist says, "Oh, king, I've finally done it. I've invented, the thing science has always been looking for. I found the universal solvent. It'll dissolve absolutely anything. It's amazing." And, he brings the king a bottle of this stuff. And the king, because in riddles kings are perfectly logical beings and much smarter than alchemists, just says, "Nah, chop off this guy's head. He's a liar." Or something to that effect. I don't remember the riddle exactly. And the riddle's question is why? How could the king know he was lying? And the answer is, well, if you had a bottle of universal solvent, it would dissolve the bottle. It would dissolve. That's what universal solvent is. It dissolves anything. You couldn't put that in a container because it would dissolve the container. And I don't know if that's necessarily exactly true. Maybe it's really slow universal solvent and you could put it in a bottle for a while. I don't know exactly what universal solvent is assumed to mean. But anyway, just this tank of universal solvent is kind of funny. I don't know if this is... The other thing is, water is sometimes called a universal solvent. It doesn't actually dissolve everything, but it sure dissolves a lot. Actually, is that true? Am I remembering that wrong? Is water a universal solvent? Water is often referred to as the universal solvent because it has the ability to dissolve more substances than anything else, but not everything actually does dissolve in water. So I don't know if this is a joke saying, oh, it's just a tank of water. Or if the joke is, oh, yeah, it's universal solvent, but of course that doesn't really exist. Either way, kind of a sensible chuckle. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path. Including the starting position, here's all the spaces visited at least once. So I feel like we've done this before in previous years. Obviously not exactly the same, but here's a way to describe a path. Count the places it visits. Before leaving the mapped area. Okay, so we have a fixed size grid here, and we care about what happens inside it. Of course, the guard will continue forever out the bottom of the puzzle, but we aren't counting those squares. This is the kind of puzzle that makes me wish that I built my own Advent of Code library to have shared bits and pieces between problems. Because the number of times I've done oh, you're doing things in a 2D coordinate space and you need to know about directions and deltas. I've done it enough times in my life. I'm not that excited to do it again. But I also don't really want a shared, even between my own projects, Advent of Code library, because A, it makes the videos kind of uninteresting if I say, oh, let me just import my, let me just import the thing that solves the problem. What's interesting about that? I don't know. So, and it's still a little test bed to try out any new ideas I might have about how to do things. At some point, I was doing these problems with map from, pair of int to the board state. And at some point I said, I really should learn how arrays work in Haskell. And I did problems like this using a two-dimensional array, which is like maps but more efficient, basically. So it's not a complete waste of time to do this over again, but it is a little bit exhausting. A little bit oh, I really don't want to start, so what if I just talk for a while about the reason I don't want to start? Then I won't have to start. So we could, an array. I guess this is not a bad opportunity to show off some of the, what's kind of interesting about Haskell arrays compared to arrays in other languages. There's a few things. One is, just like anything in Haskell, you can have lazy arrays where the values aren't computed until they're needed. And so this can let you build an array that, where one cell depends on another cell. That's not going to be relevant here. One thing that is relevant is you get to choose your own coordinate system for arrays. It is not required to be ints to ints. An array in, for example, Java has to be one-dimensional, and you can only index it by ints from 0 to the size -1. That's how arrays work. If you want an array of arrays, you can have that, but it's an array where the contents are another array. In some languages like C or C++, you can actually have a two-dimensional array mapped into a one-dimensional array, basically by the language, or n-dimensional mapped into one-dimensional, but it still has to be indexed by ints from 0 to size -1 in whatever dimension. Whereas in Haskell, you can map arrays by pretty much anything that can be converted to an int in some way, and you can describe to the runtime how to interpret these things as ints. And so If you want, you can have an array where the lower bound is 2 and the upper bound is 8. And like, of course, the runtime maps that onto, okay, yeah, well, we're actually, if he asks for index 2, we're going to give him what's actually at index 0. You know, if he asks for index 8, we'll give him what's at index 6. But you don't have to, like, tie yourself to this 0, 0 thing. So if it's convenient, you can use arrays where, like, the top left corner is 1, 1, which is the way, as a human, you would maybe view this, you know. You listen to Sudoku players, right? And they talk about row 1, column 1. They don't talk about 0, 0. And so you can just have that be how your array's indexed if you want. You can index from bottom, you know, make the origin kind of conceptually wherever you want. Anyway. So I guess let's just get started on defining some array primitives. Well, defining the grid, I guess. I've said before, if you're going to copy anything from my Haskell setup, don't make it be my my project setup, I guess. So my Haskell setup in general, don't copy it. It's pretty, I don't know. I have like this whole stack layer that I don't even know how to use, and it just sets up a cabal layer that I also don't know how to use. And I edit this file, which I think is technically auto-generated, but I just never regenerate it again. I don't know how it works. I thought I got rid of all of these. Oh, I only edited source files, didn't I? Haskell source files. When I did my like DOS to Unix everything commit. So they're still left in the cabal file. Oh well. That's just gonna have to be the way it is. So if we want an array, do we want to think about things in, like, how do we want to think about directions? That's one thing you always have to decide when when building an array problem, I feel like, or a grid problem, is you can talk about directions by naming them, say north, south, east, and west, and say that if you're going north, your next direction is east, and so on. Or you can say, like, okay, north is positive 1 in the y direction and 0 in the x direction. And turning right from that should be, you know, positive 1y but 0, or positive 1x but 0y, or something like that. There should be, if we only needed to turn right, which for the moment we do, it seems like there should be a simple function that, like if you imagine this array were the complex plane, turning right is multiplying by I, like multiplying your vector by I or by minus I or something like that, right? And so there ought to be some... Oh, isn't there... Where is that there's... I feel like vec2... There's like a vector library that has a whole bunch of useful types like this already, isn't there? What would that be called? Vec2? I don't know. Package vec, fixed vectors isn't really what I want. It's in some Edward Comet library. I remember that. It has a very Comet feel to it. Is it called vector? Module here. I can't remember any of the, like, what was interesting about the vector that made me remember it. There was a function called basis. Linear, it's in linear.vector, is that right? I think that's the one I'm thinking of. So what's the deal with linear? It has linear algebra on the free vector space. Who the fuck knows what that means? I took 1/4 linear algebra in college, and I was terrible at it. Yeah, see, told you Edward Kmet was involved. And it has all these useful tools, I think, for working into a two-dimensional space. And so maybe I don't have to reinvent everything myself. So if I have like, what is a V2? A V2 is just like a pair of AA, right? Yeah. So V2 of A has 2 A's in it, strictly. Okay. R1. What does this mean? It has at least one basis vector. Okay. Distinguishes between X and Y, but might have more. Okay. Oh, no. Oh, the counterclockwise perpendicular vector. Oh, that's promising. So I think I want that, right? All right, let's, I don't have linear in my Cabal file, do I? No. Linear. Okay, so you guys can't see that I'm making some edits there. I guess EX. Oh, what the fuck is E? Come on, Edward, please. It's always such an adventure to understand. Like, he's very advanced. He's a very powerful wizard, Edward Kmet. He understands many things about math that most people do not, and it's not. He shouldn't have to document all of mathematics in every library he makes, but there's a lot of it that I don't understand. Okay, E. The basis element. God, it's a lens of... Oh, no. Okay. Well, negated is kind of cool. Basis. Huh. All right, I don't know. But I think linear V2 is a thing that we want. So let's see if I can do anything with that. Oh, is it going to have to build linear? Yes. Okay, fine. Everything else is already built, but I added a new dependency that apparently is not included by all of these, so now I have some more work to do. So I think I do want an array. Well, let's look back at what else is in here. Is there like some type I should use? Like a 2D vector, contents. Like what is a linear dot matrix? Do I want one of those? Okay. Okay, this is called matrix product. Okay, this is not. It takes an M of T of A, where M is some functor, T is foldable, and A is a number. And it also takes an N of T of A. So why does it have an M of T of A and a T of N of A? I don't know. I don't think I need this. Okay, great. Oh, although M22 of V2 of V2s? Does that make sense? Oh, I see. This is a fixed size matrix. What? I guess that makes sense for like doing graphics or something. Oh, got the Ludet infinite or indefinite. I don't even know. Okay, so it's clear I don't need this. What's in linear.vector and linear.v? These might be interesting. N-dimensional vectors. Okay, well, I definitely don't need those. Oh, of course. I'll need the operations on free vector spaces. I might, too, but I don't know what it means. So this is sum vectors, difference vectors. I mean, that's kind of interesting. But since my vectors are just going to be v2 of int, I can just add them with plus, I think. This is where E is defined. That's cool. Yeah, I don't need this. Oh, unit's kind of cute. Unit of x? That's okay. Cute. Okay. So I don't think I need anything except linear.v2. So let's become familiar with what's in linear v2. A v2 of a is just a pair of a's. And it has all these nice instances. So you can do things like add it. And then a bunch of other stuff that, like, I don't understand. It's applicative. Is it a monad? I don't remember if a pair of a's is a monad or not. I feel like it shouldn't be, but maybe it is. It's a monoid. It should be an applicative, that's for sure. Where's applicative? It's up here. It's a monad, huh? Okay, I mean, I don't need to know this, but I want to know how. It's some weird thing, right? Okay, return A is just make A in both slots. Fine. To bind it to F is to... just call F... What? Oh, right. Yeah, this is this weird... I never convinced myself, like, why this satisfies the monad laws. So the idea is to bind to F, you extract the two elements, the x and y of the vector. You call F on x, which will return a new vector x and y, and you throw away the y part of it. And you call F on y, which will, of course, return a new vector, a new xy, and you throw away the x part of it, and then you glue them together. I don't know why this satisfies the monad laws. At one time I tried to explain it to myself, and I don't remember if I was able to be satisfied and just forgot or never understood. But okay, I don't need this. It just, like... curious, I guess. All right, whatever. So it has all these instances. We don't need most of them. And underscore x is a lens. Oh, but I'm just going to do pattern matching because I don't want to know all any of this stuff. xy is a lens from t of a to v2 of a? What is t again? It's a space. Something that understands x and y. Okay, whatever. Yx is the opposite directional lens. Huh, that's interesting. Okay, so perp is counterclockwise. So we should be able at this point to play around, right? Yeah. So if I say unit x, no. Because unit is from a different... It was from one of those other... Well, it's kind of... Okay, so where is unit from? Because that is kind of interesting to me. If I look at the contents, it was in linear vector, I think. Yes, operations on free vector spaces. So it's saying x, the unit on x is a positive 1 in the x dimension and a 0 in the y dimension or direction, which is correct, of course. And if I say perp of unit x, this is going counterclockwise. So if unit of x is going, let's say, to the right, although of course this is arbitrary, this is part of how we define the coordinate system. We'll say positive x is to the right, as you would get in a graph. Let's define our coordinate system as positive x is to the right, positive y is up. Those are both valid. You could say positive y is down, and then they're both reasonable coordinate systems. But this is the one you would see in like high school algebra. So if we're going in a unit in the x direction, then perp, which is counterclockwise, right? Am I in the wrong? Perp. Counterclockwise. So that's going up. We should get 0, 1 from this. Actually, I mean, let's take 4, iterate perp. Yeah, 0, 1. That's going up. Then minus 1, 0, that's going left. 0, minus 1, that's going down. So this all great. Perp does what I thought it would do. I can say it doesn't matter, but there we go. Now we don't get the warning. Okay. And if we were to say, for example, unit x plus unit y as a v2 of int, unit shouldn't be capitalized. We get, 1, 1. It added them together. Great. Okay. So let's say then that our type coord is a v2 of int. And type grid, let's say a grid of A, because maybe I'll want to put something into this grid other than just like what's there, other than like the initial conditions. Maybe I want to decorate the grid with something. Probably not, but it seems fine to make this parameterized. A grid of A is an array indexed by coord of A. Right? This at least type checks, yes? No, because I have to import array, of course, in v2. Yes, that type checks. Great. Let's define a type for, grid contents, I guess. Well, so what about directions, right? A direction is also a coord, but I don't want to get them confused, right? Because a direction in our context really is a coordinate that's only whose there's only 4 valid directions, really. And so using a coord for them is sort of like incorrect. And yet, like, I do want to just use a coord for them because it's going to be a nuisance to, like, actually confirm that they're always correct. Like, the disciplined thing to do might be to have a new type that I can only construct. Like, a new type wrapped around coordinate that I can only construct if it really is a unit vector along one of the two bases. Is that something you can check with, like, with data with linear? Can you say, like, hey, is this one of the bases or parallel to a basis? I don't know. Okay, so here's a question, I guess. What is basis as a list of v2 of int? Yeah, it's x and y, both positive plus 1. Okay. I thought maybe it might include the negative versions, but of course it doesn't. Okay. Well, we'll just say our coordinates are, I mean, I don't know. Maybe this is an opportunity to practice some discipline. Why not? So let's say new type direction is a direction of coord. The problem with this is that then I won't have, like, you can't use plus on these, you can't use mappend because that has to, like, always be valid. Well, yeah, like, it's incorrect to add well, that's fine. I guess I won't ever be adding a direction to a direction. Okay. Maybe this is interesting. This is creating a rod for my own back in a way, like, because it's just going to be more inconvenient to deal with than just using a coord directly. But I think it might be interesting. And a way to make sure that I never get coordinates and directions mixed up, even though they're, like, represented by the same thing. So do I want to draw? I mean, I probably want to, like, show at least, and probably eq. Ord can't hurt. No one's ever been sad to have an ord instance, right? And the thing is that we need... Well, I was going to say we need a make coordinate function that, like, is a smart constructor that checks that it's a valid coordinate. But I guess we don't, right? If we were exporting this to another module, we would need to give them a way to, like, say, hey, give me a new direction or something. But all we really need to have is... I mean, since we're in the same module as the new type, we can, like, break all the laws we want. I'm kind of trying to create an API that allows me that as long as I only use that API, I can't accidentally break a law. And I think the only operations we need on directions are add a direction to a coordinate and rotate a direction, right? And I need some initial one, which we'll just say north. So let's say north is a direction. North is a direction of... I guess I want... So what do I need from linear vector? I need, like, unit, at least, right? It's the direction unit y. going up, right? So does this still type check? Yes, you're not using X yet, but that's okay. And I don't even need turn left, so I can say turn right is a function from direction to direction. Turn right is, I mean, negate, I guess. Perp. Turn right of direction C. Like this, right? Where perp is from linear vector? No, it's from linear V2. Okay. Yep, still compiles. Great. And then we just need step. Takes a direction and gives you back and a function from and gives you back a function from coordinate to coordinate. Alternatively, it takes a direction and a coordinate gives you a new coordinate. So step of direction. I call this C, I guess because it is a coordinate, but D and C is C plus D, right? Yes. So that's interesting. That should, in principle, be all the operations I ever need on directions, right? Let's just confirm that, like, what is turn right of north? Positive in the x direction. Great. Okay. Take for iterate turn right of north. Is this all the normal things? Plus y plus x minus y minus x. Yes, those are all correct. Okay. So that's kind of cool, I guess. As long as I don't write any other functions that use this direction constructor, I can't ever break the law that a direction is a unit vector, is a basis vector, is parallel to a basis vector. There. That I think covers it, right? Because minus x and plus x are both parallel to basis vectors, even though only one of them is a basis vector. Okay. Now, because this is all in the same module, there's nothing here to stop me from pattern matching on directions. But as long as I don't do it, I don't know. I mean, I could put it in its own module, but like, who does that? Okay, so I have a grid, I have directions, that's all cool. I'm gonna need sets at least. Is this actually... Yeah. So, yeah, I mean, I'm using GSC 2021, which lets you write qualified on either side of the import, and I guess this is the side I want it on. They're both kind of confusing, but it's fine. So I'm going to need sets because I'm going to be... I'm going to be like marking all the places that have been visited by putting them into a set, and the set will let me remove duplicates. I'll need more things from array for sure. I'll need bounds at least. What else is in data and array? containers is not really what I want. Here it is. So we're in data array. What happens if I just look in here? No, I don't want to search. I want like... So we have array. Oh, it won't be in array, will it? I'm looking for bounds, and that'll be in IX actually. No, it's here. Okay. Okay, so what do we have in the index package or module? Which is, okay, it's in base, I guess. But data IX is its own module. Okay, so we have in range, right. So I'm going to want that. Okay, so we want bounds. Probably don't need the actual IX type itself. I just want in range, and I think that might be it. Data array, I have bounds. Gonna need more than that for sure. Now, I thought, like, a year ago when I was doing array problems, there was some new development in the array package that made it easier to construct arrays, and, like, it just wasn't in the stackage snapshot I was using or something. But I still don't see it in the documentation for data array. Oh, I see. Data array re-exports everything in IX, so I can just do this. Okay. I don't need IX specifically. So we're going to need, I guess, array. I probably want list array, actually. Maybe. You know, what's funny, actually? I'm just thinking about how I'm going to end up building the array, which is... Presumably, I'm going to call list array or array or something with, like... I'm going to parse the input, and I'll look at row 0, and I'll say that's at x equals 0 in the array, the first row. So actually, my direction is not... I should consider north as going down in the y direction, because we're going to use the computer science coordinate system instead of the high school algebra coordinate system, where 0 is the top of things. Okay, fine. Why was I thinking about this? Because it just kind of sucks to build arrays. You know what might be interesting? Let's go back and look at 2023. How did I build... Because I had to do something very similar here at some point, right? So what if I just search for array? Let's do a little bit better here. No, stop. There. Don't look at all my Git repositories or whatever. So here we have an I array. Interesting. A grid is a v2 event, so this is something I did previously. Wobbliness. I wonder what this problem was all about. make array. What the hell is make array? Oh, it's right here. It's a list array from 1, 1 to the length of the rows and the length of the head of the rows, sure. Concat of rows. Well, this looks pretty simple, doesn't it? And I'm just like, instead of matching some digit, I'm going to match some grid element or something, right? Let's just borrow this whole function. Because it's just like, I don't want to have to figure that out again. Here's me like, oh, wouldn't it saying, oh, this is why I don't have a library of shared code. But then when I want to share some code, I just go surgically extract it. Okay, so I guess I qualified this as A. And I'm calling list array, huh? It makes sense to not just wholesale import a whole module, really. So maybe I just like won't import any of this stuff. I'll just refer to it as a dot whatever. So what is this function all about? We need to well, grid element. The thing about this is there's one element of the grid which is special, which is like the location of the guard, right? And I feel like I did some of this before too. Build an ST array, which I don't need. I can have an I array, but I know somewhere I had like a thing that tracked coordinates while it was reading and could emit like, oh, here's the place where the start is. That was like the pipes problem was last year, wasn't it? Maybe? Did I use maybe... did I use RWS at some point? That's probably the interesting one, right? Day 20. Has autosave data, speaky. No, I didn't use it for this. It looks like I didn't finish. This is the day I quit. Okay, sure. That might be unreleased footage. Who knows? Maybe that's the first time that file has ever seen the light of day. But I know I used like writer or something. Oh my god. So my input on this day, a set of located ints and a map from coordinate to symbol. This looks promising. Yeah, so I did this whole measured token thing where I figured out how wide each token was. I parsed lines, and then I collated them. Line was many times match either a number, a blank, or a symbol. And then each of those things knew how wide they were. Fold M, what the fuck is this? So I was writing both a set of located ints. These were for like gears or something. Gear ratios, I don't remember exactly. And a map from coordinate to symbol. So there wasn't exactly like a single special one, but I did, you do have access to like X and Y here, right? Sort of. So I guess you could, yeah, I mean, zip each row with a Y coordinate, zip each cell within the column with a Z, an X coordinate, and then you'd have X's and Y's for each. And you could use that first, you could just process that list twice, right? Once to build the array, and then once to figure out the starting position, I guess. Okay, maybe that's what I'll do. So I guess we should talk, I guess, about like what the input even is then. So let's say data grid object is basically just I don't know. Entity, I think, is what I usually end up calling these. It's either empty or obstructed, they call it. Okay, so my input is going to be, data input is input of two things. A coord, which is the starting position of the guard. Well, yeah, let's actually say it's a direction and a coordinate and then a grid of entity. Obviously our direction will always be north, but this is kind of like, this input type contains everything we need to, like, we'll maybe be changing this as we'll compute a new state. I don't know. Oh, do I want a direction and a coordinate to be their own, like, guard location? Should that be a separate type? Let's say no. But, like, it probably should be, right? Because when I step the guard, I'll compute a new direction and a new coordinate, right? So let's do that. Data guard. Do I want to just call it guard? Like, all we care about the guard is the direction they're facing and where they are? I don't know if I'll need eCoord and show for any of these. Most of them I assume I won't. Maybe I'll want show, but probably not. But like, it doesn't hurt to add them. So this is actually going to be an input containing a guard and a grid entity. Okay. So we don't have to keep track in the grid of where the guard is. So we can just, I don't know, let's say entity, oh, I haven't even imported my... I don't even need regex for this, right? Like, yeah, we're matching some grid elements, but like map, I can just say map entity of dot is empty, entity of hash is obstructed, entity of anything else is error. Oh, well, actually there's a difference. We want this. It's also empty. Entity of anything else is error unexpected. X, right? So that sort of seems plausible. Does any of this compile at this time? A.array, sure. Because I did change how I wanted to import that. Yes, that's true. What else? I haven't changed... Right. This doesn't give me the whole input. Right. Right. I haven't done this whole zipping stuff yet. Prepare input equals... let indexed equal map. No. I want to decorate each of these with the position they're at. Label lines, maybe? Label lines of input. So what would the label function be here? Label of rows is, I want to zip with lambda y, zip with, no, not lambda y, of course it'll be lambda y row, zip with lambda x c to yx c, right? Does this make any sense? I think so. Except I have to provide arguments to this. Zip with this lambda. Actually, we're saying it starts at 1, right? So 1 r Zip with this lambda, integers from 1 up, zipping with the entire row. Yeah, and then this shouldn't need... Zip with this of 1 rows. This type check at all? Yes. Okay. So now I have labeled. So I don't even need list array, right? I can actually use array because I have each cell labeled with exactly the position it's at. So I don't need to do this length thing. A.array, oops. From 1, 1, oh, I do still need length. Yeah, that's true. I can even, at this point here, instead of just calling C, I can say entity C, right? And then this would be suitable for input to array. Input of find guard. Oh, the problem is, no, if I call entity here, I've lost track of the fact that there was a guard there. I've thrown that away. Okay, C. And no, it's called array, isn't it? Array. It's a dot array. What's this? And map entity. It's not rows, of course. It's indexed. Well, we could just say input. Map entity over indexed. And where find guard is undefined. Concat. Where did the concat come from? Oh, this function is no longer used. Indexed is the wrong type by a lot, it looks like. There are some other errors first. A length of head of input. Oh yeah, that's wrong. I actually do want indexed here. Okay, the list of errors is dwindling. Oh, right. Map entity second, because we only want to look at the value that's there. Didn't help. Oh, I see. Right, now I'm actually, I need to return the indices of each. Okay. So it's actually not quite that. I need to map fmap entity. Leave the coordinate as is, but modify the data there by calling entity on it. Closer. One error left. You expected a list of coordinate and character, which I agree with. What you found is a list of list. Oh, so the concat was necessary after all? Yeah, I guess that's true. There you go. Is that really it? That can't be right. No, that just made it worse. Okay, great. So indexed is a list of rows, and each row is a list of cells, and we just want out a list of cells. So why can't I just call concat here? Oh, did it need to be in parentheses and I forgot to do that? Nope. This is a nightmare. So an array from 1, 1 to oh, wait a minute. Is this messed up? I'm actually, I mean, this is not the problem, but I think I might have these two mixed up because isn't X first? Yeah. Should be like that. But okay, so indexed is a list of pairs of coordinates and entities. Well, not entities, characters, right? Do I need another map there? Because index is a list of... Yeah, that looks a little bit more promising. Okay, it's not any more wrong than what we had before, but it looks sort of the same. What's the difference here? Oh. Of course, I'm calling yx. Oh, also yx. Well, I guess if I label them with y first. No, because I'm actually referring to x and y. Well, I just don't have to refer to x or y, I guess. I can throw those away and say this is the direction of v2 of yx. So if north would then be downwards y is 0x. And then I can actually leave this the way it was, because that's sort of a convenient way to, well, but yeah, I don't know. I mean, I guess I could just have these be x and y, right? Why am I messing with this? I'm defining the coordinate space as I do this. So I can just say v2xy, and that's the only place it needs to go, right? So length of head index, that's our x range. Length of index is our y range. That makes sense. We're calling v2 there. Okay. Great. So we're not using x. Okay, so it parses finally. So that's cool. Does it work? If I say prepare of dot hash new line hash dot new line error. Great. Just what I wanted. Why? Oh, because I called find guard and that doesn't exist. Sure. Okay. So if I said, oops, let input ignored grid equal the pair of dot hash new line hash dot new line in grid. There. Yes, so it's parsed something. Is it correct? It's an array where the 1, 1 to 2, 2. 1, 1 is empty, yes. 1, 2, which is... Oh, I shouldn't have defined a symmetrical one, huh? There. x1, y2, which is the bottom left, is empty, which is as we desired, right? Yeah. X2, Y1 is obstructed, and that's the top right, and that's correct. Yeah, this looks like it works. So find guard of... You know, why do I even have this let in? Why don't I just have indexed be this, so it's accessible to everything? Like so. I can just say guard here, right? Because now guard is in scope. So guard is... First item, this is such a partial function, but it's sort of implicit, just like our parsing is. I allow myself partial functions while parsing, basically, because I assume the input will be well formed. In a production application, you would have to do something different. Guard is the first, is the head of C, where... C oh, actually it's do I have a type for this? It's called guard, right? Yeah, guard north and is that all I need to write? Yes. So now, if I say prepare on this, it should fail because there is no guard, right? Yes. But if I put the guard here, It says, the guard is facing north. 0, -1. Yes, that's north. And he's at x1, the left, y2, the bottom. Correct. Okay. Now, these two concats I would sort of like to get rid of. I mean, I guess the only time I use indexed... no, I do kind of need to know its size here. Okay, well, I'll leave it alone then. So let's celebrate a little bit. Hello? Have I typed some bad character? I'm not allowed to type anymore? Okay. Who knows? Yes, stage this. Stage this. There's nothing funky in here. Yeah, alright. Day 6. Parser and types, I guess. Just so that I can't screw this up. I know it's been forever and we haven't really done anything. That's kind of part of the experience of Advent of Code for me. Is getting, refamiliarized with how the heck all this linear stuff works and this kind of clunky input parsing. And the fact that making arrays is kind of a nightmare. But when you're done, you do get a kind of nice array type. So that's something. So we should be able to implement part 1 somewhat easily now, I think. Let's go look at the problem statement again. What exactly do they want me to do? Should we consider the location the guard started at? Yes, it's even highlighted. Which is good. So really, I think what we're looking for is we want to write like a step function. Iterate, but go move 1 step for the guard. And we will iterate that indefinitely, and we will take while the list of places the guard has been is in bounds of the grid. The list of places the guard has been. We don't care about the locations the guard has been. The directions the guard has faced. So... part 1 returns an int. Part 1 of input of well, maybe what I can just do is leave the input undestructured and write a step function. So, okay. We're going to say const 1 or whatever. Actually, just 1. Where there's going to be 2 functions I want. Step, and I'll give them types, even though, like, for internal functions, it's traditional to, like, not have to write types. I just want to have straight what I'm doing. Step is just a function from input to input. Well, actually, isn't it just function from guard to guard? That makes sense, doesn't it? Because we're not changing the grid at all. Okay, so maybe I will, after all, destructure the input up here. And I suppose for now, step equals undefined. I need like a function that maybe I'll just say face is a direction and pause is a coordinate, and now I have an extractor function for coordinates. So input of G. Oh no, guard and grid are the same. They start with G. Guard, grid. That's fine. I can't just call them. I can't call either of them G. Is S dot. I assume it's called size of take while in bounds. Is that the name of the function from? Oh right, we're not importing it anymore. We're referring to it qualified. But it comes from IX, which in range. In range of A dot in range of A dot bounds of grid. I don't know how to like get these indented in a way where like it's actually like not all on the same, like right in Java or something, you would indent like foo.bar.baz.whatever under. So like I kind of want to do that, and I can never figure out like what the Haskell convention for doing that is. I don't know. Like where does the dot go? I don't know. Set size, take while, in range, bounds grid, S from list, I guess. So we're going to convert it to a list and then get it from a list. Map pause iterate step applied to the guard. Does that make any sense? It does compile. Okay. So if we had a step function, this would do something. Currently we don't. The good news is step, I think, is pretty simple. Step of B and C. I'll say P for position. We've been calling it coordinates earlier, but now that I've named it pause, I feel like I have to. Blocked. It's going to be hang on, it's called, of course, guard of D and P is guard of D prime and P. Oh, I already have a function called step. Okay, I'll call it move. I don't know. Move in the new direction by P, or move from P, where D prime case a dot lookup. Oh, what is the order that it takes that shit in? It takes the array and then the index. So case grid lookup move dp. So if you could move in the straight direction, oh, this isn't going to work, is it? Because when I'm about to walk out of bounds, I'll segfault here instead. Or, well, I'll have an error. Let's see. I'll have p prime be move dp. So just try to move forward. And d prime if in range we'll call this inbounds, I guess. If in range in bounds of p prime and didn't I just have something else useful in my... There we go. Is equal to obstructed. Like if the place you're trying to move, is there like a way to look up in an array like, hey, if it isn't here, no, not really. Okay, whatever. So if the new position is inbound, and what you find there is an obstruction, then the new direction is turn right from this. Otherwise, it's just the original direction, right? Does that make any sense? It seems okay. It's a little bit annoying that I have this inbounds check repeated here and here. Like, I feel like it would be cleaner if here we detected we were about to move out of bounds and like signaled that we should stop iterating somehow, but just emitting an invalid position seems fine. Okay, does this compile? Yes. X is still unused. So, okay, what if I just said... Oh, main will fail because I haven't read my input yet. Okay. I feel as though I have probably made an error. All right. Well, what would happen... First of all, this was out. Yeah, I did reload, right? Okay. So I prepared this. What if I just said part 1 of this? The guard visits 2 locations, which is true. What if I put in another row here? was just empty. Should visit 3, right? Of course. And if I put an obstruction here, what should the answer be? Guard starts lower left, moves up, can't move up, turns right. So it should still be 3. It's not 3. Why not? So what if I just said it would just give me the list of all the places the guard visits? One, 2, and 1, 3? You couldn't go to 2, 3? Do I have him accidentally turning left? I was pretty careful to make this right. But maybe my coordinate system is inconsistent somehow? Let's do a little bit more surgery here. Let's say I didn't... let's say we did this. The type is wrong. So the guard begins facing in the negative y direction, which is up. That's what we wanted. Then he moves up. He's still facing negative y. So what's turn right of direction of e2, 0, and minus 1? It should be 1, 0, right? It's minus 1, 0. Okay, maybe because I'm using y as the first coordinate. I see. Hang on. So, but I'm not. X is the first coordinate, right? What? Unit of y as a b2 event as a coord. If you're walking north, if you're going north and you turn right, you should not be facing west. How did I... That makes sense. Perp of... How did I come to the conclusion that I was getting... There must be something wrong with my counter... Like, what I understand counterclockwise to mean? I don't get it. Perp of E2, 0... Perp of north. No, because north is a coordinate. So that's positive x. Why is that called counterclockwise? Like, am I stupid? Where was perp from? Perp is from here. A counterclockwise perpendicular vector. If north is minus y, which, I mean, which it is in our coordinate system, but maybe the problem is my coordinate system is mirrored from the one that Ed is modeling? If we imagine the high school algebra coordinate system where minus y is down, what's perpendicular from that? Left. That's sorry. What's counterclockwise from that? Left. No, that's clockwise. So counterclockwise from minus y in the high school algebra coordinate system is plus x. Is that what I get? It is. So the problem is my coordinate system is actually mirrored in a weird way, I guess, to where counterclockwise and clockwise are flipped. I'm kind of looking at it from... Oh, that's funny. So imagine the coordinate plane, right? Imagine it's a flat surface, and instead of looking at it in front of you, as you often do in like an image on a TV screen or a monitor or whatever, or you're looking down on the coordinate plane like it's in a book or on a graph on the table or something, right? From that perspective, counterclockwise from down is right. Yes? We can agree on that. But suppose that you got under the table and you looked up. It's a glass table, by the way. You looked up at that same coordinate system. You would find that the meaning of up and down, positive y and minus y, had stayed the same. But positive x and negative x had shifted. The positive x direction would be to your left. And for that reason, counterclockwise and clockwise have reversed meaning. So that's the problem, is that I'm using a coordinate system that is mirrored from what I thought I was using. And like, yes, perpendicular makes sense, but like my basis is a little bit weird in a way, I guess. So if I say actually, it's not negate, it's just perp of D. And I now say, what's turn right of north? It's positive x, of course. I'm really hitting the wrong keys. Iterate, turn right from north. Now we get minus y, which is up, north, plus x, which is right, east, plus y, which is down, south, then minus x, which is left, west. These are the directions I wanted. Okay, interesting. So if we go back to this, What does the guard do now? The guard goes to 1, 2, and then 1, 3? Wait a minute, what? Am I lost? Oh, right, because this isn't in the order the guard is doing it. I've made it into a set. These are just the places the guard has visited. 1, 2, 1, 3, and 2, 2. That matches with what I intended to happen. So I think we're now sort of maybe in business. In map pause. Okay, if I run main, I get an answer this time. Okay. Well, I appreciate that Eric gave us an input where if you have the guard walk in the wrong direction, you don't get a wrong answer. You get a loop that is clearly an indication you've made an error. So let's submit this number and see what the website thinks of that. 4711. The right answer. Okay, great. Finally. So, I guess there's one thing I should do, actually, which is just stop importing X, because I never use it. I don't want to use it. And let's just pretend it always looked that way. So we fixed turn right. Why did move change? Oh, I renamed it to step. Oh, we should probably include this in the previous commit as well. There we go. Yeah, so we added the pause function to the guard, which I use here. So I think it makes sense for this to be part of the part 1 commit. Okay, let's say we're happy with that. Day 6, part 1. What's part 2? While historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab guard's post on the walls of the closet. The last few months. Returning after what seems like only a few seconds, the historians. I feel like the sentence structure is wrong here. Returning after blah, blah, blah. The part after the comma should be what you do, not what the historians do. Anyway, the historians explain the guard's patrol area is simply too large for them to safely search the lab without getting caught. They're pretty sure adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way the guard will get stuck in a loop, making the rest of the lab safe to search. They'd like to know all the possible positions for such an obstruction. But you can't put it right where the guard is now. Okay. There's 6 different positions where a new obstruction would cause the guard to get stuck in a loop. Uh-huh. Doesn't matter what you choose, so long as you can put it there without the guard noticing. Make sure you can find one that minimizes paradox. How many different positions could you choose? Okay. Sure. So we need a new version of this that will report both out of, well, that that kind of reports whether it fails for an infinite loop reason or an out of bounds reason, right? So, like, iterate step is something we need, right? For part 1 and part 2. And the rest we kind of have to change, right? So let's maybe do this. But step needs a grid, is that what I called it? Yeah. So does this still work? No, because inbounds is wrong. Kind of annoying. Well, let's just make this a top-level function as well. Inbounds, grid of anything, and a coord and returns a bool, is that right? Not quite. Couldn't match. Iterate by stepping over that grid, please. There we go. Main 4711. That's still all correct. Okay, so we've extracted inbounds and step. Fine. I mean, honestly, we could make this a little bit more. Well, I can make it more general, but then I need to import the IX type, so I just won't. So we basically need to so step is going to give me all the ways a guard has been, basically, right? And step, I guess, will return something out of bounds when so we can, okay. We can iterate over the list of guard dispositions returned by iterating step. If the list ends, we'll know this was not a place to put an obstruction. And if the list has any duplicates, we'll know we succeeded. Right? So that's the idea. We'll do something like this, but we won't build a set of just the positions. We'll fold over the list. Does that make sense? I think so. Because that should allow us to early terminate in both cases. To terminate correctly in both cases, I think. Input guard grid is due, I guess. Let's say C. Oh, how do you modify an array? I have, because I think the arrays I have are immutable, so derived arrays maybe is what I want. So array, list array, accessing, yeah. Construct an array identical, except it's been updated by this list of associations. Yeah, that's what I want. I'll just put one thing in this list, and it'll give me a new thing. Okay, fine. So give me a coordinate to try from a dot bounds of grid, probably. Now I'm really annoyed because let's see, import. Okay. Import control.monad qualified as I'm just going to qualify. Don't use M. I always use M for map. I don't want to get confused myself by it because I want a function named guard from control monad, and I already have one named guard. So here we go. Control monad guard. C is not equal to the pos of the guard. So C now is all of the places you could put an obstruction. Let G prime, grid prime, be, let's see, what is the order? It wants the array first, so grid slashed with C obstructed, right? I guess I'll just return infinite loop of grid prime. And I'll have that return a Boolean, I guess. So length filter identity of this thing. Where infinite loop of G is fold R. So I want to fold. Maybe I don't want to fold R. Maybe fold R is the wrong thing. I want to write some function over the results of iterating step. Right? If I iterate step, I get a list. Okay, we're just going to write it by hand. I'm sure there's a pretty way to do this. Go S empty, I guess, of iterate step of step grid, step G of the guard? That seems plausible. Go of scene G if S member G scene, I think is the order it wants these. I always forget this. Do I have data set open? I don't. Data set member takes the key and then the set. Fuck, I got it wrong again. Okay. Wait, maybe that was right. It takes the member and then the set. G is the new position. Yeah, okay, this is correct. So if we have seen this position before, we return true. No, hang on. Go scene empty is false. We failed to find an infinite loop. The guard walked to some place that we ran out of places to see the guard going. Go scene G's. If we've seen the guard at this exact position before, it's true. Otherwise, it's go of S insert G into scene and G's, right? So like this, okay, fails to compile, whatever. Oh, it's not bound. How do you, I want range. Is that right? No. How do you... If you have a... Given as the bounds of an array, how do you just get a list of all the indices the array could have? Indices of the array? Okay, fine. Bounds. Compiles. Does it work? Well, it's sort of natural that this would take longer than the other one. It shouldn't take a million years, I would think. We are doing this in GHCI. This is like the slowest way you can run a program. But I feel like if it doesn't complete pretty quickly, we actually have a loop. Like we have, it fails to ever complete. Yeah, so, okay, I'm not convinced this is working. Well, I called part 1. What if I just called part 2 on this? Yeah, this one should not take that long to finish. Okay, something's wrong with part 2. Oh, right. We're just iterating forever. We never stop. I took out the take while because we don't want to stop when the guard walks out. But of course, we do want to stop in that case, right? So we want to take while inbounds grid prime of this. Take while the position is in bounds. So step over and over. And then while that's in bounds, okay, that makes some sense. This has got to be like, there's got to be some way that this is just a fold R, and I don't get it. But it isn't really, right? Because, like, I'm sure there's some other primitive you can build it up out of, but it can't be a fold R because, or not a trivial one. Because fold R, you have to return the initial state when you get to the end of the list. And we need to return false if we get to the end of the list, but our state isn't false, it's a set. So, I don't know. Oh, it's called G in this context. 0. There are 0 places you could put an obstruction to cause the guard to have an infinite loop. I agree. In a grid this small, that must be true. But it returned, instead of just crawling into a loop and dying. This is taking a while, but it's plausible. Why don't I pop over here, stack, run. Let's actually compile it and run it compiled and see if that's any better. I mean, it does seem as though we have a termination condition. How big is this input? 130 by 130. It's like 10,000? No, 20,000? More than that, I don't know. $17,000, okay. Oh, it finished. 1,505. I'm surprised it's that high. Because didn't we just say there's like 17,000 positions, period? And 10% of them, you could put the guard into an infinite loop by dropping an obstruction there? That's way higher than I would have guessed. But okay, let's see. How many different positions could you choose? It's too low? You don't mean too high? Uh-oh. So we obviously can't put it exactly where the guard is. Find all the positions where you could put the guard in a loop. Can't be at the starting position, but it could be right in front of them. Yeah. So what am I not understanding? because I do have part 1 correct. It is correctly, like, I know how to navigate the grid. I've parsed it correctly, and my coordinate system isn't screwed up. So something in part 2 must be wrong, I think. So we're filtering identity, saying how many trues were there in this list? We're choosing as our coordinate any of the indices of the grid. Let's make sure that that function is actually what I think it is, right? Okay, the one in GHCI is still running. Like, I'll prepare on this. It's an input. Guard grid equal this in grid. All right, so that's just the array part. And if I say the indices of that grid, there are 6 of them. That makes sense. We're not allowed to put them outside of the grid, are we? It's not, I don't think it's said explicitly, but like in this, I guess the guard like normally leaves through here. If you could put, oh, we're not really handling. What if the guard tries to turn right and there's something in front of the guard there? Like, the guard is walking forward, they see there's a wall in front of them, and they decide to turn right, but to their right is also a wall. Do they turn around in that case? I imagine so. Yeah, see, look. It doesn't say turn right 90 degrees and then take a step forward. Like, I see. So the issue, an issue, is I bet there are some cases where you can create an infinite loop by creating a little pocket the guard walks into and has to turn back around or something. Or like they have to turn left because, yeah, of course we're going to be creating situations like that. And our implementation has the guard like, see, oh, there's a wall right in front of me? I'll turn right and step into the wall that's there. And they just get to go through the wall, which is cheating. I bet that's what's wrong. Well, that's a thing that's wrong. I bet that's why we get the wrong answer. So it's not actually the case, necessarily, that there's anything wrong in part 2. Part 2 might be correct. And actually, it's this that's wrong. So we need to compute d prime more carefully. Basically create a list of all the candidate directions you could turn: straight, right, behind you, left. and then choose the first one of those that either lets you out of the grid or lets you walk into a non-obstructed square. So D prime actually is head of filter walkable of iterate turn right of the original direction, I think is a way to look at it. Walkable of a D prime, oops, say equals. Is either it's not in bounds or it's not obstructed. Alternatively, I guess we could say you can De Morgan this, right? You can say it's not the case that it's in bounds and obstructed. That seems plausible. Uh-oh. Right, the problem is walkable of D prime isn't using D prime. Thank you for that warning. I guess I'm not actually using P prime up here. It was only intended to be used to compute D prime. So try moving from P in the D prime direction. And then, unless it's in bounds and obstructed, then it was walkable. Binding for D prime shadows the existing binding. Yeah, is that okay? I think so. I mean, I don't know. You're supposed to have B warnings clean, right? There you go. Real long name. Well, let's do this. Where? There. How about that? Okay. So let's run that and see if that was the only problem. It'll take a minute. I hope we still get 4711 for the first one. We could actually probably check that by running it in parallel, right? 4711 we do, okay. Because in GHCI, it's lazier, right? It's like, it prints the first thing it sees and then waits. Whereas at the terminal, it's line buffered or something, so it doesn't print anything till it gets all the results. Line buffered makes sense. Maybe there's some other explanation, though. I guess while that runs, let's look at this and pretend we're coming up with other ideas for how it could be going wrong. Not in bounds. And it was good to confirm that we didn't break part 1, because we did some surgery on step, which could have broken part 1. it's finished. 1562. What did I enter last time? 1505. And that was too low. This is bigger by a small amount, which matches with what you would expect if you had some error condition that occurred in a small number of cases. So let's try 1562. That's the right answer. I'm glad I had that insight about what I could be doing wrong, because I don't know how else I was going to figure it out. I was going to have to, like, I don't know, work on a smaller input and get visualization tools for why it's producing the wrong thing. Or maybe Eric was generous enough to have the example input include a position where you could put a thing and create this kind of wall walking, but maybe not. Maybe Eric didn't think of anyone being as dumb as I am, making that mistake. Yeah. Right, we needed all of that. I mean, we'll just commit all of this, right? Nothing. Big 6 part 2. All right, I mean, as usual, it took me longer than I would like to admit to solve the problem, but I'm not really in this to solve everything quickly, right? I'm talking things through. I'm having ideas. I'm having my struggles. And if you watch the end, I bet you enjoy that kind of thing, so I don't have to apologize to you. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.